Hello, everyone. Good to see you. Especially like today, I guess the part of the world is still in holiday mode, but some of you are so eager to learn and came back for the workshop today. Today is the one of the smart contract track workshop in the Polkadot Scalability Hackathon. It's about ink and Rust, so that you can learn about like how to build like safe, fast, and smart contracts with Peter from Rogue Team. So let me invite Peter to the stage. Cool. As we are now entering the third week of the hackathon, I guess some of you already have idea and started to build. Some of you are still finalizing like what to build, given the next 2 weeks is the very, very busy building period. So we are so excited to see that what's going to be built in the end. Hi, Peter.
Hello, everyone. Thanks for having me.
Good to see you. Very excited to see you. And thank you for coming back to give a workshop about the ink, because already Rogue Team were helping us to spread like a ink workshops throughout the perhaps almost like whole year. Like last year we had a chat first, right? And then we had a two education in the run. And now this is in the mode of the hackathon, giving the Polkadot now, giving a lot of attention to the smart contracts. So we are very curious. There are going to be two different types of smart contract coming into this hackathon, one built with ink, one built with the Solidity. And we are very excited to onboard more of the builders who are interested in ink. So do you want to share your screen?
Yeah, let me go ahead and share my screen. We will do this window here, and I'll move you guys over here. All right.
Fantastic.
There we are.
Yes, very excited. Okay, floor is yours.
Awesome. Well, once again, I'm super happy to be back presenting at Encode Club. And if you like building secure smart contracts, then I think Ink is the place for you. My name is Peter White. I am one of the co-founders at Rogue, and I've been in Polkadot for about 3 years now. I used to work at Parity, and now I work at Rogue, basically trying to make Polkadot easier to build on. And one of the things that we really, really are passionate about is ink. And some of the reasons for this is because ink is native to Polkadot. It was built for Polkadot, and it's the smart contract language that was just designed with Polkadot's vision and technology in mind. So what do I mean by this? A simple example is the Polkadot SDK is built with Rust. And ink is just Rust with a little bit of magic that allows the Rust program to be a smart contract on Polkadot. So this technology is just very, very like interlaced. And here's a simple example. So here is a piece of code, and here's another piece of code. What the actual code is doing isn't important, but it's a cross-chain message. And my question is which one is in a Polkadot SDK blockchain or parachain, and which one is in an Ink smart contract? And the thing is you can't tell the difference because it is the exact same code. Because Polkadot SDK uses Rust, and because Ink uses Rust, we can use the same crates, the same modules, and the same exact code in Ink that you might be able to use in Parachain. So it's just, this interface is just super seamless. Contract, but with parachains. And furthermore, because Ink is just Rust, it allows you to do this cool thing where if you build a smart contract in Ink, you can actually, if you can build a smart contract in Ink, which is just Rust, you can take that code, say your smart contract blows up and you need to go and get your own parachain. You can use the same Rust code and actually port it over into a pallet to build a parachain. So it's not going to be directly one-to-one, it's like the same exact code, but it's going to be super close because most of your logic will be in Rust, and it just makes that transition much easier. It saves you time, saves you money because you already have the code written. Now, I'm saying Rust a lot. Rust. Now, why is Rust such an important thing? Now, I like to show this slide. Rust is not just a Web3 language. It's a language that is used in so many companies across so many different industries. The Polkadot SDK, all of it was built in Rust. Linux, the only other language that Linux trusts to have in its kernel is Rust. So it's just C and Rust, that's it. And it's because of the memory guarantees, the security guarantees, and the safety guarantees that Rust provides. It's why like Microsoft is rewriting Windows, part of Windows in Rust, why Google uses it, Amazon uses it, Apple uses it. So many companies use it. And personally, if I'm building a smart contract that potentially has a lot of user funds flowing through it, I would want to build it in a language that is the most secure and safe as it can be, especially when you're working with immutable code. You want it to be as correct as possible the first time around. Now, Ink also has a cool thing where we've been building Ink in a decentralized way. Ink is no longer maintained by just one company, but instead we've got an alliance, the Ink Alliance, that is consisting of Ink core developers that used to work at Parity, Polytope Labs that's behind Hyperbridge, Rogue, which is behind Pop Network and other tools, and Verto, which is behind the Cravelo network on Kusama. And together, we are building and pushing forward Ink thanks to the Polkadot Treasury, which actually funded us to continue building it. And what we've been doing for this first treasury proposal is actually making Ink v6. Now, the main things that Ink v6 has is Polka VM compatibility, which is what this whole hackathon is about, is actually getting to use and build with the Polka VM. So we've made Ink compatible with Polka VM and Palette Revive, and we've also made it Solidity compatible. So now your Ink smart contract can talk to Solidity and vice versa. So we're super excited to be able to present this and have some people actually start building with it. Now, before I jump into it, I'm going to show you this messy slide. But basically, I tried to consolidate a lot of information for you all just on this one slide, so you can click through the links. If you scan the QR code, it will take you to the slides. I will also post this link later. But the first link is just use.ink. This is the main Ink website. It's got all of the docs, and it actually just had an overhaul. So I'm happy to kind of show you around a little bit. So we had this whole website done. It's pretty cool. It's got a lot of information, but the docs will probably be the most useful thing for you. And one thing to note, you do have to use Ink v6 for this hackathon because that is what is Polka VM compatible. Anything like Ink v1 won't actually work to deploy it on West End. With Palette Revive, which is the new contract palette, some things changed that made debugging Ink a little bit different. So we've got this contract here that we've set up that shows you a bunch of different ways to actually debug your Ink contract. Now, one thing to note is that Palette Revive is still under development. So there's some functions that were in Ink in the past in Palette Contracts, which is the older one, that still are kind of being ported to a new functionality. And these ones are considered unstable. So the unstable functions are not compatible on West End right now, but you can test them locally. So like you can test your contract locally on an Ink node with unstable functionality. And if you click through to here, you can kind of see what I mean by unstable. I'll also show you later. Here is an Ink to Solidity contract. And this is also one thing to note is currently Ink v6 is only on the master branch. So you have to use the master branch for Ink. Now we're going to set up a cargo contract or Ink CLI, which will set everything up for you and it'll use the proper like master branch. Now, let's actually go ahead and jump into it. So the first step is let's actually set up our tooling. The first step is the Ink CLI, or what is commonly known as cargo contract. Now we need to actually install it first. And this one we also have to install from the master branch. I do have this nice slide for you here, which has a few of the commands that we'll be using. So if we go ahead and copy this one, head over here. If we paste this in and run this, this will actually go ahead and install cargo contract. I already have it installed and it takes a bit, so I'm not going to run it right now. But when you run this, it's going to take a bit to build and then install it, and then you'll have access. So if you do cargo contract, you can see what version it's on, and you can kind of see what are some of the commands. So it does quite a few things. And basically what cargo contract is it's your, your developer buddy. So it's what allows you to actually build the Ink contracts. It's what links it to PolkaVM and builds the PolkaVM instructions. It generates metadata. It generates your contract files. You can deploy from cargo contract. You can call the contracts. You can do quite a lot with it. So yeah, as you can see, you can add a new contract, build, upload, instantiate, so on and so forth. So the first step is let's actually get a contract added. So if we do cargo contract new, and we would call it Flipper. I already have a Flipper contract that's pre-built, so I'm just going to call it Flipper in code. That creates a new contract, which we can see here. So let's go ahead and look at what this contract is. So it's going to produce a few things for you. It's going to produce lib.rs and a cargo.toml. Those are going to be your the first things it builds. See, so this is the new contract, cargo.toml, lib.rs. So if we go into our toml file, this includes like all of your dependencies and things that you would add. The name of the contract, what your name is, and note a few things. So first, we are using the master branch for Ink, and this is the GitHub repository. And it actually comes with the unstable host functions enabled by default. But like I said, not all of these, I'd recommend trying to do without the unstable host functions for this hackathon. But if you want to play around with some of these things on a local node, I definitely recommend to try to activate this and play around with it. Now let's actually look at the contract and kind of walk through what some of the, what is the contract. So first is this Ink macro here at the top. This is basically, everything in this module is the Ink contract. So it's going to generate a bunch of boilerplate code that kind of allows this contract to then be deployed into Polkadot. We have a struct here, which is kind of the main struct for our contract, and it is annotated with this Ink storage macro. And you can only have one of these for your entire contract. And this defines the storage of your contract. So basically, this is the data that will actually be persisted and remain on chain. So you can add new fields to this to do different things. You can add vectors, you can add values, account IDs, lots of different things here. And then we're going to add an implement block for our Ink storage struct. Now, Ink has a few different things. First, it has constructors. Constructors are, as you probably know, the things that actually run when you initialize the contract. So in Ink, you can do a cool thing. You can have multiple constructors. So we have one called new and one called default. With this new one here, we are taking a value, and then we're instantiating the contract. This self is just saying, okay, we're going to create a new one of this flipper, and we're going to have it with this initial value. And then we've got this default one here, which just does default value. So it'll start it at false. And then we have the messages. And the message is the function that is basically callable for your Ink contract. And we've got two types of these. So you've got one that is mutable and one that is read-only. And the way you can tell the difference is if you've got this mutable annotation or just the reference to the contract itself, that'll kind of say which one is which. So this one, we can actually modify values. We can modify the storage and store new values on chain. And this one is just getting values. I think in Solidity, it's called a view function. So this is what that is equivalent to in Ink. So this is a view only function where you're just reading a value. Now, also note you have to keep these as public. So the messages have to be public. Now for this one, it's a super simple contract. We're just flipping a Boolean between true and false. Now, before I jump into actually deploying this and building it, I just kind of want to briefly go over just a couple things that we'll go into more detail later. But first is in Rust, you can actually add the test directly into your contract file. So it makes building and testing actually really, really nice, because you can just define the test and basically write Rust to test your functionality without ever having to deploy it. So it just makes it super, super easy. Basically, you write your code, write a test, run cargo test, see if it works, and then go back to writing some more code. Now, we also have end-to-end tests, which are built into Ink as well. And these allow you to test your code on an actual live node. But yeah, let's actually go ahead and deploy this contract. Let's build it and deploy it. So first thing, we would run cargo contract build, and we're going to do a release build, which optimizes the code and makes it smaller. So if we run that, this will take a little bit longer, but I have it pre-built just to save time. And you can notice that it outputs a few things for us. So it outputs this flipper.contract, flipper.polkavm, and flipper.json. So the JSON file is the metadata for your contract. And I realize that when I look over at the screen, you guys may not actually be able to see what I'm showing. Okay. One second. Okay, so super sorry about that. It looks like you guys were not able to see what I was showing for the past few minutes. Let me kind of backtrack a little bit here. So we are using Cargo Contract. It's a tool that we installed with this here. Now, when we do Cargo Contract new, this creates a new contract for us. So Cargo Contract new, it's going to create a new Flipper contract. And when you go into that contract, it gives you a couple things, the cargo.toml and the lib.rs. Cargo.toml, right here, this is the manifest file for your contract. This is where your dependencies are, the name of the contract, things like that. Note that cargo contract right now, when you use the master branch, it's going to use the master branch for Ink. Now, in the contract, we have a few things. So we've got this Ink contract macro. This is the macro that says, okay, everything in this module is the contract. It's going to have storage, it's going to have messages, and events, errors, things like that. This storage macro says that this is the storage for our contract. This is what's actually going to be persisted on chain, and you can continue updating it as you call it. And you can add new fields to it here. And then this implement block is where like your constructors go, your messages go. So like we've got this Ink constructor, and we've actually got two Ink constructors, because Ink allows you to have two. So if you have a constructor, you can just add this Ink constructor, and now you can have multiple Ink constructors. Let me see if there is a chat. Okay, so what version of Rust am I using? So I am using 1.85. Yeah, so I would say maybe try to upgrade to 1.85 and see if that lets you build cargo contract. All right, so yep, those are the constructors. Those will actually run when you instantiate the contract. And let me pull up this chat again. Okay, awesome. Let me know if that works for you. And then we've got the messages here. So the messages are the functions that can actually be called for your Ink contract. So they need to be marked as public. And we've got two types of these. So one of them can actually modify state, modify the storage of the contract that is stored on chain. And then the other one is a view only. The difference is that you've got this mutable here that says we can mutate the state, or we've got without that, which says this is a view only function. We cannot mutate the state. We can only read values from it. And then I showed you briefly the test, where it's like in Rust, you can define the test directly in the contract. You don't need any extra tools. You don't need to go and use JavaScript or anything like that. You can just live in Rust. So it makes the feedback loop of development really, really tight. It just makes it very, very pleasant to work with. And then end-to-end tests. These are actually to test on a live node. Okay, let's go ahead and actually build this contract now. This time you guys can see, and you can see what I'm doing. So cargo contract build. We're going to run that. builds the contract, and it's going to have three things outputted for us. So we've got the flipper.contract, flipper.polkavm, and flipper.json. The flipper.json is your contract's metadata. The PolkaVM is the actual code, the blob of bytes in PolkaVM. And then the contract file includes the code and the metadata. This is what we will actually deploy. So let's go ahead and deploy this now. So we're going to use right now the contracts UI, which normally you would find at, oh, wrong screen, there we go. Normally you'd find it at ui.use.inc. But this one is not, this is still on Inc v5. So we're going to use an alpha version here. It's Inc v6 alpha.netlify.app. And this is actually linked in the slides. So you can see here, we're connected to West End's Asset Hub, and we're going to go to add a new contract, upload new contract code. And I will go, so this is my Flipper contract. You go to target, Inc, and we have the .contract file. That's what we're looking for, because this has our code and the metadata. So if we paste that there, it'll pull up everything, including what compiler I used. So I used 1.85, the version of Inc and the contract hash, along with all of the functions, constructors, all of those things. So if we press next, this will actually pull in what constructors we want. So we've got the new constructor or the default constructor. We're going to go ahead and use the new constructor. We're going to set the initial value to true. And note that it's going to dry run the contract for you. It'll actually try to deploy this and see if it was a success or not. So we can press next now. We're just going to use Alice in this case, upload it and instantiate and sign, and there we are. We have a contract that is now deployed on West End. Here's its address, here is how much value it has, and here is how we actually interact with it. So here is the caller, and here is the message that you want to call. So first, before we modify anything, let's look at what the current value is. So if we press get here, it's going to say, okay, return value is true. Now we can go ahead and flip it. So this one will actually modify the state of the contract. It says that the contract call will be successful. It does a dry run and will calculate the gas, that the required gas to actually run this contract call. And then we can call it. So we'll go ahead and sign that transaction. It's going to take a second, and then, oh, there we are. So it flipped the contract and it shows some of the events that were emitted. Now, if we call get again, we can see that it is now false. So this is basically the contract UI. It's a pretty simple thing, but it just helps make development a little easier. Now, you can also do this with cargo contract. So cargo contract, and then you can call instantiate. So this is basically saying, okay, what is the private key you want to use? I recommend not using any production keys, just development keys here. This says to execute it, not just do a dry run. And this is instantiating it, so we're deploying the contract. So the default constructor is the new constructor in cargo contract, so we're not specifying that. And then what are the arguments we're passing in, and where are we deploying it? So if I run that, and I'm going to press yes, and this will actually, in a second, it should deploy it as well. So you can do all of that from either the contracts UI or cargo contract. The contracts UI is a little nicer because it uses the metadata. So generally, I'd recommend using that. Now, I don't know, this seems to have got stuck. Maybe it's just taking a second to get into the block. But we can go ahead and look at a few other things. So let's see here where, let's go through the test. So we've got this message here, which flips the value. So if you go into the test, you can see that we can create a new contract instance, and then we can get the value of it, verify it's false, and then we can flip it. So it's basically just like you would do a test in Rust, you can do a test here. So if we were to run cargo test, Oh, okay, that's going to take a second to build, so we won't wait for that. But you can write your tests just like this to then test your contract before actually deploying it on chain. Now, another thing that makes it super easy to test is we can use the Ink node. It's another thing that I think is good to set up. So in the slides, we've got the Ink node linked here. And the Ink node is basically a local development node that includes the transactions in the block instantly. So it makes it super, super quick to test. And you don't have to actually have West End tokens to test or anything like that. So you can just break some things really, really quickly, all locally. So here's the Ink node. We can install it. This one is actually on crates.io. Crates.io is published. So installing it is pretty easy. So we just do cargo install Ink node like this. You'd run this command, and then it'll go ahead and actually install the Ink node for you. Once again, it's going to take a little bit, but once it's installed, you should have access to it. So if I do this, I can see, all right, Ink node on version 0.43.1. So now I'm going to actually go ahead and start it up. It's just Ink node --dev. And that is starting. Now, the Ink node is also, we changed the name. It used to be Substrate Contracts node, but now it's just Ink node. So if you see Substrate Contracts node, don't get confused. That's what the Ink node used to be. So that's deployed. That's running. And we can connect to it here on Polkadot.js. And we can see that it's running. Now, it's not going to produce blocks in the normal way, where it's going to have it's going to count up 6 seconds, and then it's going to produce a block. It uses what's called instant finality. So as soon as you send a transaction, it's going to be instant, and it's just going to make things quicker. So if we go to local node now, so we're back on the contracts UI. We go to local node. It's going to go ahead and connect to that, and we can try to upload the contract here. So same thing, upload new contract, add new contract. We're going to add our flipper. Now note here, it says, okay, account unmapped, and account ID 32 tried to interact with the palette without having a mapping.call. With cargo contract, it'll actually automatically do this for you. We don't quite have that with the contracts UI. So it's pretty easy to do. If you go to the Polkadot.js and then developer extrinsics, you go to revive, you need to call this map account here. So if we submit this transaction, the account will be mapped. And then if we go back to our contracts UI, we can now see that it actually will be a success. So it's kind of nice to have this dry run where it'll show you if something is going to fail right away. Now we can deploy it. It's going to be the same thing as the last time. It's the same contract. But yeah, we deployed the contract, and now we can interact with it all locally. Now, the reason I showed you this Ink node is for something that I think is a very, very useful tool to have when you're developing this. It makes it really, really fast to be able to develop, which is these end-to-end tests. So these will actually use the Ink node. When you run the end-to-end test, it will start the Ink node and run the test and actually deploy the contracts on that local node. So here you can see that we're testing that you can instantiate the contract. So we have a client which is actually interacting with the Ink node, and you call things like we're going to instantiate, we're going to submit it. It has a call builder for you to actually call the contract, and then here's a more advanced one where we're actually flipping the values on chain. So I'm not going to go through super detailed how this works, but in the Flipper contract, it has the examples. And like I said, if you have that Ink node installed, you can then run these end-to-end tests, and it will do the test locally on your Ink node. And it will even map the accounts for you. Okay, so those are kind of the basics, the setup, the tools that we're going to use. Now, I think let's go into maybe just some of the Ink examples we've got out there. So let's go back to here. So we've got here, I can add a new link to that, but there is Ink examples. Should be, all right, let me pull this up. So Ink examples, this is a repository with just a bunch of examples that you can build Ink contracts with. Now, Note that all of these are on Ink v5.1 right now. However, the code will still work in an Ink v6 for most of them. Some of them may use unstable host functions, which you can't use. But let's say, for example, we go to this ERC20. This is a kind of common contract that, that will work if you just make one small change to it. But I'm going to go into some of the things that Ink offers for you. And of course, you can find all of this in the docs as well. All right, looks like I got a chat message here. Okay, awesome. I'm super happy to see that the install worked. And yeah, that should just work to continue building good Ink contracts. Okay, so we've got this ERC20 contract here, and I'm just going to kind of walk through some of the things that it defines. So as I said, we've got this Ink storage. This is the main storage for your Ink contract. And it has the total supply. It's got balances, which uses a mapping. Now, the mapping is a cool data structure in Ink because this one is actually optimized for Ink's storage. So instead of having, it's optimized for Ink storage. So like normally, if you do a read in Ink, like you're going to read from storage, some data structures will actually pull all of that data in all at once. So it's going to be very heavy on your gas. While this one will allow you to query just the one item that you want. This is going to map from an account ID to a balance. Same thing here, it's just a little more complicated with a tuple. And then we can define events as well. Now note the Ink topic bit right here. This is actually unstable. So for this ERC20 contract to work, if you remove this Ink topic, this will actually build and you can run it. And an event is as just as in Solidity, you can emit these events to then use them in your front ends or wherever else you need to use it. So we've got a few events. We can define errors in Rust as well. So it's an enum of different errors, which then once again you can use these in your front ends or you can use these to debug your code. Now, here we are. It's just a more complicated constructor. So we are initializing the contract. We're going to start it with some initial balance. So we're going to start with the total supply. We're going to make the caller the owner of that balance. So we call an insert here. So now we're inserting a new entry into the mapping. And then we're going to emit an event in the constructor. Here's a getter, because once again, it doesn't have that mutable there. So there's just a few more getters. So like here, okay, balances is a mapping. It's a data structure that's called mapping, and we can call this .get on it. Now, when you call this .get, something to note is that it actually returns an option. It's something that can exist or it won't exist. It's something or it's nothing. So then we have to use this .unwrap, right? So Rust, this is one of the reasons, this is one of the ways that Rust helps keep your code secure, where it doesn't have like null values or things that maybe aren't instantiated. It kind of forces you to properly check if something exists. So in this one, we're using an unwrap or default, which will say, if this value exists, we will use that value. Otherwise, just use 0, because that's the default for balance. All right, so this is just more getters. We're just going to keep kind of going past these. Let me find, okay, so the way this contract is set up in, okay, yep. So let's go to the transfer function here, or maybe transfer from to. Okay, so here we are. So this function here, this message, this is just a helper function right now that is used by the other ones, but takes an account ID and the account ID to send to. Here we're inserting into the mapping, and then we make the events. So really what I'm doing here is just kind of walking you through some of the basic syntax that you can kind of see around Ink. So it's nothing super, super exciting to just kind of look at this stuff, but this is just some of the basic examples. And if we go through the docs, we can go to the Ink v6 docs. it walks you through a lot of this already. So if you go to getting started, you can find setup, you can create a project, and then we can go into all of the basics. So it will walk you through how to store values, read values, mutate storage values, and a lot more. And also things like cross-contract calling as well. And in cross-contract calling, you can call other Inc contracts, but you can also call Solidity contracts. So here we are. So this would show you how to call a Solidity contract using something called build call Solidity. Now you can see it is a little more low level for this build call Solidity. We're going to continue to abstract this away and make it a little easier. But let me go to the actual contract, the actual Solidity contract example. So if we go to here, back to this slide, Inc to Solidity. So here's an example that actually allows an Inc contract to call a Solidity contract and vice versa. Let me scroll down a bit. Okay, so here we are. So this one, we're going to call a Solidity function called setValue. And we have to generate the function selector manually here. So we would do this. We have this helper function here, which calculates the Solidity function selector based on how Solidity defines its function selectors. And then we call this build call Solidity, which is a call builder that helps you do this. We call this callee is the Solidity address, gas limit, transfer value, and then here this is this exec input is what you would use to set up the actual call. So we're saying, okay, this is the selector we're calling, which is calculated here, and we're going to use this argument, this 77, and that will set the value in the Solidity contract, and then we can invoke this, and this will actually now call the Solidity contract. And then here's just another example in get. Now, like I said, this is in the slides here. Now I can kind of keep just going through different things, but if at any point you've got a specific question that you want to ask for Inc, go ahead and just drop it in the chat. And I'm happy to address that. Okay, so let's do what other things are useful to know when building with Inc. Like I said, some things are currently unstable. So like these upgradable contracts in Inc. Normally this is something that will become stable, but it allows you can actually upgrade the code directly with an Inc contract. So there's a bunch of examples in the Inc examples that goes through that. So in this Inc examples repository. Yeah, so like I said, if you got any questions or anything like that, please drop them in the chat and I can go over them. But we can go ahead and what do we want to do? Okay, so we can actually try to build a basic contract that does something, and we can have it inspired by something in examples. Now we don't have too much time left, but I can maybe show you a few more things in Inc. So let's see what we can do. Oh, sorry, I lost my slide. Okay, got a message here. Can you call Solidity contracts on a different chain? So that's a great question. Right now, you can when Inc and Pilot Revive are stabilized. So with Inc, we actually have access to XCM, which is cross-chain messaging. So here's an example contract XCM. And this will actually allow you to send cross-chain messages to other chains. So if and when, basically when Pilot Revive has stabilized some of these functions, XCM will actually be one of them. So with this, you'd be able to create a call that calls a Solidity contract, say, for example, on Moonbeam. You could create an XCM that actually does do that. However, right now, because we're still kind of in an alpha state, this is not possible yet. but it will be possible soon. And yeah, there's an example here. If you did want to play around with something like this on testnet on Paseo, we do have some things that we're building. The Rogue team is building that allows you to call stuff and query stuff. But for the hackathon, you can't actually do that because it doesn't use Inc v6, at least not yet. Okay, so let's see. Okay, so let's go ahead and let's modify our Flipper contract a little bit. Let's go ahead and we can just do something simple. Like let's allow the contract to transfer balances to some account. It's a simple example, but we can actually modify some stuff and write some stuff. So the contract has an option to be payable. So if we say transfer value, you would need to, if you want to say, I want to send the contract some money and then have it either save the money or just transfer it to someone else, we would need to mark it as payable. So when you mark it as payable, this now allows the contract to receive funds. So with this, we can go ahead and get the transfer value. And transferred value, I believe, is what it's called. And basically this environment here is saying, okay, here's our Inc contract and here's the whole environment for it. So there's a lot of helpers there that are useful for you. Let's see. So if we go to the Inc docs, which is another super useful thing to have, Inc docs, traits.io, a different kind of Inc docs. These are the Rust docs for it. Here we are. So this is much more detailed docs that you can look at to actually like see what kind of types are available, what kind of functions are available. So let's go ahead and hold on, where are we? Let me go to oh, sorry, should have been, here we are, environment. I'm in the wrong thing. Let me go to developer documentation. Okay, these are still the same thing. Sorry, I'm got a little lost right now. Either way, I'll post the link later, but there's some docs that will show you like everything that is in this environment here. And like transfer value is one of them. So we can take this transfer value, which is basically when I send value to the contract, I can pull this transferred value and actually see how much was transferred to my contract. Now, let's go ahead and add in a parameter to say beneficiary, who's going to actually receive the money that we're going to transfer. And this is going to accept in account ID. Now, one thing that makes this a little tricky is that Pilot Revive now uses an address that is Ethereum compatible, while if you're using Inc, it actually uses a lot of things that are Polkadot native. So if I'm calling an Inc contract, I might expect to be using a Polkadot native wallet. So this account ID is actually saying, okay, this is a Polkadot address. This is something that is 32 bytes long, while an Ethereum address would be, it would use a different type, which is this address type. So all of your contracts in Pilot Revive, Inc contracts included, we'll use this address type, which is 20 bytes long. So it's an Ethereum compatible address. But if we want to transfer value to, say, somebody's account that is a different account, a Polkadot native account, then we would need to use this account ID. And so we can go ahead and call, and I believe it's transferred. Let me pull up the examples to make sure that we are using the same API. All right, so here's what I'm going to do. If you go to the Ink repo here, there's actually a bunch of integration tests that use Ink v6. So it's in Ink, integration test, public, and these are the Ink examples. These are just the ones that have not been published in the Ink examples repo yet. So all of this here will be super useful. There's tons of Ink examples that you can use to learn Ink. So here is the example for a contract transfer. So if we go down here, so we've got the value, and then here's the transfer function. So we call the environment transfer, and we can actually get the caller. So let me go ahead and copy this guy to our contract here. And we want to change this self.environment.caller is actually pulling who called the contract itself. So we'll go ahead and change that to then call the beneficiary that we want to transfer to. And the value, we're just going to basically forward the value that's sent to the contract. And this is yelling at us because we need to import this. So go ahead and import it. All right, there we are. All right, now in Rust, let's see. In Rust, if you don't have a semicolon at the end, it assumes this is the return value. So this is equivalent to this here. So that's why when I don't have this semicolon, it's yelling at me because we don't actually have a return type set. Okay, but we can go ahead and transfer that. And this is returning your results. All right, so this is now basically all we're doing is we are taking in a value, we're checking what that value is, and then we are sending it to, we're forwarding it to the person that we set. So it's a super simple example, but it shows you a couple things, which is how you make your contracts payable. It shows you a little bit of this environment here, which you can use to get the transfer value. You can use it to get who the caller is, like that. And then there's a lot of other things you can do with it as well. So we can do cargo contract build, and this will build it. And if everything is right, it will be happy, but in this case, it's not. So if we scroll up, we can see, all right, so here's a problem, which is that this transfer now actually expects, because it uses Palo Revive, it expects an Ethereum compatible address, not a Polkadot compatible address. So we do actually need to change this a little bit. So this would then become address like that, where we have to use an Ethereum address instead of a Polkadot address. So if you're going through some of the old documentation for Polkadot, or sorry, for Ink, then if you're going through some of the old documentation, you might see it's like, okay, I can use a Polkadot account ID. But now that we're using Ethereum compatible addresses, it makes it a little trickier, and we have to do this workaround here. Now let's see, got a message. So I am using Rust Rover. I used to use Visual Studio Code with Rust Analyzer, which worked well, except the Rust Analyzer would always break on me. So now I use Rust Rover, which actually works very well. You know, we can navigate through all of our types pretty easily, except the macro there. Yeah, but Rust Rover, I definitely would recommend it. It works well. Okay, so, okay, sorry, the thing's getting in my way. So here we have to make a little bit of a change, where instead of transferring to a Polkadot account ID, we have to transfer to an Ethereum compatible address here. So this caller, when you call this caller, it'll actually be a Polkadot compatible address. Sorry, an Ethereum compatible address. Yeah, let me see. So in this ink example, here's a simple one where basically in this contract, we have this was it 10 here, which is a payable message. Payable means I can send this contract value and it can accept. And then we can actually check, okay, did I receive in this contract, did I receive 10 of whatever, 10 of Paseo or 10 of West End. And then once it has some funds in the contract, you can actually transfer it. And this one is saying, okay, give me the funds to my address, as the calling address, self-environment.caller. Okay. So, I mean, there's of course more we can do. There's just so much that makes it hard to put it all into one workshop. Really, what I would recommend is, like, if I, starting to wrap it up and answer more of your questions, what I'd recommend is really go through the examples. I'll put the examples link into the slides here. We can decrease the font. So you can find the examples there. It's a bunch of examples that are Ink v6 compatible. So you can do, there's a lot you can do with Ink. And yeah, documentation, Ink docs, and then yes, feel free to ask us questions in Discord as you start going into it. If there's something in particular that you want to try to do, then just shoot us a message and we'll check the Discord, we'll answer your questions and help point you in the right direction. But what I'd recommend first is get your tool set up, get cargo contract set up, get the contracts UI, the Ink node, and actually, start playing around to play contract. Look through the Ink examples and see if, look through the Ink example. Like I said, we will be here to answer all your questions and help you out. But yeah, any other questions, anything that you want to see?
First, thank you, Peter, for the amazing workshop. And I can say that you've thought about sharing us a lot of different resources as well. First thing is, as Peter just said, I really recommend all of you going through the example and asking questions. Now we have a full 2 weeks of amazing building period, wherein this is the timing that you can build and asking questions and make your project to next level. And especially those who are new to Ink, perhaps either take some learning curve in the beginning, but don't hesitate to ask questions in the forum, because your question might be the same question the others have as well, and it'd be beneficial that you're sharing in the open forum. While I know some of you may prefer sending questions to one-on-one, but otherwise that's amazing. And also Peter said that he will be sharing the slides in the Ink zone in our Discord server. So all the links which you couldn't copy paste, do not worry, you can go through the slide deck and go to each link afterwards. I can see Kuro is typing. The new Ink website looks great. Yes, I thought so as well. It looked really slick and nice design now, huh?
Yeah. The people we work with worked super hard on it, and yeah, we're super excited to have it out there now.
Very exciting. Cool. I think for now, then that's pretty much it. When more questions coming up, everyone, don't forget, come to the Discord server, obtain to the Polkadot Scalability Hackathon role. If you're not sure what it means, don't hesitate to tag Inco team so that we can help you out. Then you can go to the Hackathon specific channel and asking questions. Thanks again, Peter and the Rogue team. And I am very looking forward to see what kind of projects going to be built during this time. Thank you very much.
Yeah, thank you, everyone.
Thank you, Peter.